This is a quick review on organic chemistry. Organic chemistry is the study of organic compounds. Organic compounds are generally, these are compounds with or that contain carbon hydrogen bonds. So here the star player is the carbon. As we know, carbon, it has 4 valence electrons, therefore it can bond to at most of 4 hydrogens. Now this carbon can also bond to another carbon, and the rest is bonded to hydrogens, forming this molecule. So with this special property of carbon, it can serve as the backbone to form longer and longer chains of molecules. So as we go back, of course, carbon, it has 4 electron groups around it, and of course this one, the shape for this one is tetrahedral. So when we have 2 carbons that are bonded to each other, they can form this shape. So here we are still considering their tetrahedral shape for the 2 carbons. So this is the shape for uh, a compound with 2 carbons. Then if we have 3 carbon atoms that are bonded to each other, still considering their tetrahedral shape, they start to form this zigzag shape. So as we add here again, it will start to form that zigzag shape. Again, this is because of the tetrahedral shape of each carbon in this molecule. Now, this one is the molecular formula for this compound. So here in organic chemistry, we will be dealing with large molecules. So here, this one is a large molecule composing of 7 carbons, then 16 hydrogens. Now again, this one is the molecular formula for this compound. The molecular formula, it shows the numbers of each type of atom in a molecule with no information on the structure. So this formula just tells us how many carbons are here and how many hydrogens are here. Again, this does not tell us anything on how this carbon and hydrogen are connected to each other. So it does not give us any information on the structure of the molecule. Now to give the or to give us the structure of the compound, here we have the different structural formula. The first one, we have the expanded structural formula. This one, it shows all the bonds connecting all the atoms in the compound. So if we draw the expanded structural formula for this one, so this one is referring to the Lewis dot structure or the electron dot structure. So again, the other term for the electron dot structure is the Lewis dot structure. Again, this just tells us this shows all the bonds connecting the carbons and hydrogens on this compound. So here we have 7 carbons. Again, this is the backbone on this compound: 1, 2, 3, 4, 5, 6, and 7. Then of course, this can bond to, of course, carbon. It has 4 valence electrons, so it can form 4 bonds. So the rest is bonded to the hydrogens here. So ito, merong dalawang bonds na. There are still 2 bonds connected to the hydrogens. The same thing for here. Dalawang hydrogens pa. Hydrogens. Then here, we have isa, dalawa, then tatlo. Okay, so this one is the expanded structural formula for this compound. Again, this shows all the bonds connecting the carbons and the hydrogens. So, of course, if we draw the compound like this, it will take some time because again, most of the organic compounds are large molecules, so it will take time if we draw all the bonds, all the carbons and hydrogens on the structure. So we also have the condensed structural formula from the word condense. So this will condense, or this will minimize the structure. So this removes most or all the bonds in the structure. So if we condense this one, we can turn it like this one. So we have this part. This one can be uh, condensed to CH3. Then the next part, this one can be CH2. Then that's carbon, then dalawang hydrogens. The next unit, we have CH2 also, CH2. The next one, we have another CH2. The next unit, that's CH2 pa rin. The next unit, CH2. And the last unit we have CH3. So this one is the condensed structural formula for this one. So this still tells us the structure of the compound. So it tells us that on this side we have isa ka carbon, then merong tatlong hydrogens connected to this one, then the next unit is this one, it's another carbon with two hydrogens. So this still gives us some information on the structure of the compound. Then also furthermore is we can actually condense this one pa, because here we have a repeating units of CH2. We can make it like this one, so we have CH3, then the next unit we have CH2, then 1 2 3 4 5, so it's repeated 5 times. So that's CH2 open and close parentheses, then we have 5, then the last one we have CH3. So this one is the more condensed form for this condensed structural formula. So still, diba, here we have this will still take us some time to draw all the carbons and hydrogens in the structure. So we have the most common use type of a formula for most organic compounds are the shorthand formula or the line angle formula. So in this case, this still show the structure and order of the atoms in the compound, but here it uses lines instead of letters. So here, for example, here we have 7 carbons. So we draw it like this one. We have 1, 2, 3, 4, 5, 6, 7. This one is the line angle formula. So this is also known as the skeletal formula. Skeletal formula. So on this case, so each end of the line are the carbons. We have 1, 2, 3, 4, 5, 6, 7, and of course these carbons are bonded to the hydrogens. So here the hydrogens are implied. So it's not here, pero they are implied. So it's obvious that for this carbon, since merong isang bond over here, it's bonded to three more carbons, or I mean three more hydrogens, because again carbon can form up to 4 bonds. So this is the uh, line angle formula or the skeletal formula for this compound over here. Let's have another one. Let's have C10H22. Let's draw the expanded structural formula. Again, that's 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then, of course, the rest is bonded to the hydrogens. So as you see here, this will really take time if we draw all the bonds sa lahat ng carbons and hydrogen bonds. We have this carbon, then 4. Okay, this one is the expanded structural formula for this compound. Now, in terms of its condensed structural formula, we can have it this one, CH3. Then let's shortcut 1, 2, 3, 4, 5, 6, 7, 8. We have CH2. Then, so CH2, then we have 8 na CH2. Then after the CH2, we have CH3. Okay, this one is the condensed structural formula for this compound. Now, in terms of the line angle formula or the skeletal formula, we have 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, each end of this line, these are the carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the line angle formula for this compound. Now, let's go back to organic compounds. There are more than 900 million organic compounds, but these compounds can be grouped into few different classes, and this can be categorized based on the same chemical properties. And then this group, they have the same functional groups. So a functional group, uh, this is a group of atom, I mean, it's an atom, a group of atoms, or a bonding arrangement responsible for the reactivity of organic compounds. Let's discuss the first type. We have the hydrocarbons. From its name, hydrocarbons are made up of only hydrogen and, I mean, yeah, it's the hydrogens, then the carbons. So here we have the alkanes, we have the alkenes, and we have the alkynes. So here we have three groups here. This one is an alkane. So in an alkane, lahat ng bonds are single bonds. For alkenes, at least one double bond. For alkynes, at least one triple bond. Again, alkane, single bonds. Alkene, at least one double bond. Alkynes, at least one triple bond. Now we also have cyclic hydrocarbons. These are cyclic, so their shapes is ring. So here we have this one. This one is cycloalkane. Again, it's alkane because lahat ng bonds are single bonds. Then we have cycloalkene. We have at least one double bond in the compound. So these are cyclic hydrocarbons. Their shape is ring. Then this are acyclic hydrocarbons. So they are not on this ring shape na hydrocarbons. Okay, let's start with alkanes. Again, for the alkanes, let's try to name this compound. So again, it's based on the number of the carbons. Again, each of this, merong carbons 1, 2, 3, 4, 5, 6. So pag 6 na carbons, we look for the prefix first. So we have 6. So for 6, again, that's hex. So this one will be named as hex. Then this one is lahat ng bonds are single bonds, meaning this is alkane. Then for alkane, the suffix or the last part will be ane. So this one will be hexane. Again, that's hex because 6 na carbons. Ane because this one is alkane. Again, alkane pag lahat ng bonds are single bonds. Okay, so let's have another one. So here we have another uh, compound over here. So here we have a substituent. So we have an attachment uh, to our parent chain. So on this case, actually, first we need to identify the longest carbon chain. So we have 1, 2, 1, 2, 3, 4, 5, 6, 7. So I think this one is the longest. Then we have next, identify all the substituents. So this one is the substituent here. The next, we number the carbons of the parent chain. So again, this longest carbon chain, this one is the parent chain, So again, this is our parent chain over here. Now we number this one to give the substituents the lowest number possible. So of course, it can be from left to right or from right to left. Again, we should give this substituent the lowest number possible. If we go from left to right, 1, 2, 3, 4, 5. So this will have number 5. But if we go from the right to left, this will have 1 and 2. So in this case, we'll go from right to left to give this one the lowest number possible. So we'll number the carbons as 1, 2, 3, 4, 5, and 6. Now let's name this compound. So here we first name the substituent. And first we need to identify its location. So it's attached to carbon number 2. Now this one, by the way, this one is an alkyl group. This one is a common substituent. Then it's composed of one carbon. So again, this one, merong carbon over here. Then for the naming, it's still the same. For one carbon, that's always meth. Then here it's not methane because methane, that's a completely separate na koan. Here, this one is connected to the parent chain. So again, pag alkyl, we use the suffix -il. So this one will be methyl. Okay, so we have a methyl attached on carbon number 2. So that's 2-methyl. Then after the substituents, we name the parent chain. The parent chain is composed of 6 carbons. So this will be 2-methyl hex. Then again, lahat ng bonds are single bonds. This one is hexane. So this one is 2-methyl hexane. Let's have another one. So here again, we identify the longest carbon chain. That will be this one over here. The next, identify all the substituents. This one is the substituent over here. Let's name this one. It's composed of one carbon. So again, for one carbon, that's meth. And again, this one is an alkyl group. So this one will be methyl. Now let's number the carbons on the parent chain. Again, we must give this one the lowest number possible. If we go from left to right, that will be 1, 2, 3, 4, 5, 6. So that's 3 if we go from left to right. But if we go from right to left, 1, 2, 3, 4, this will have number 4. So on that case, we'll go from the left to right to give this one. Okay, 1, 2, 3, 4, 5, and then 6. So let's name this one again. First, we name the substituent and its location. That's 3-methyl. And then this one is a hexane, right? The parent chain. This one is 3-methyl hexane. Another one, let's have this one. So again, first identify the longest carbon chain. 1, 2, 3, 4, 5, 6. This is the longest carbon chain here. Next, we identify all the substituents. So this one is the substituent over here. This one is isang carbon. This one is composed of dalawang carbons. So this one is a first, let's have this one. It's 1 carbon. So that's meth. Again, for 1, that's always meth. This one is methyl. Then for this one, we have dalawang carbons. For dalawang carbons, that's eth. So this one is ethyl. Next, we number the carbons on the parent chain. So again, we should give the substituents the lowest number possible. So we'll go from the right to left. 1, 2, 3, 4, 5, and then 6. Let's name this one. So for the naming, we have here methyl, then ethyl. So we have here 2 substituents. On this case, if the same substituent occurs more than once, location, okay, it's based on number 5 here. If there are 2 or more different substituents, they are listed in alphabetical order using the base name. So on this case, we have ethyl. That's E before M, right? So again, that's based on alphabetical order. That's E before M. So let's name this one. Again, first we have the ethyl. That's attached on carbon number 4, 4-ethyl. Then we have methyl on carbon number 2. That's 2-methyl, 2-methyl. Then we name the parent chain. It's composed of 6 carbons. So this one will be a hexane. This one is 4-ethyl, 2-methyl hexane. Next, we have this one. Again, first identify the longest carbon chain. We have this one over here. Then identify all the substituents. We have this one. So 1, 2, 3, 4, 5, 6. Okay, next, we number the carbons on the parent chain to give the substituents the lowest number possible. So we should go from the right to left. 1, 2, 3, 4, 5, 6, and then 7. So this one we have 2 substituents. This one is isang carbon. This one is methyl. Also, it's composed of 1 carbon. This is also a methyl group. Next, we name this one. So here we have a methyl on both 2 and 3. So on this case, we name this one as 2, 3. And then this one. Then we have dalawang methyl. Pag dalawa, we use the prefix. So pag dalawa, we use the di. So this will be dimethyl. Then we're done with the substituents. We'll go with the our parent chain. So this one will be 2,3-dimethyl heptane. Next, okay, so let's have this one. So we have, again, these are alkanes. Now this one are the alkenes here. So let's name this alkene over here. So we have, this is composed of 1, 2, 3, 4, 5, 6 carbons. So how do we name this one? So we have, again, hex for 6, right? Hex. And then this one is a double bond, so hindi na hexane, it will be hexene. So again, for double bond, for alkene, we use the suffix "-ine". So this will be hexene. Also, we need to tell the location of the double bond. So here, we also need to number the carbons here for us to tell the location of the double bond. And it's the same thing. It must have the lowest number possible. So we should go from the left to right again to give this one the lowest number possible. So that's 1, 2, 3, 4, 5, and then 6. So here the double bond started on carbon number 2. So here we have this one will be named as 2-hexene. Okay, so again, that's 2 because the double bond started on carbon number 2. Then we have hex because it's composed of 6 carbons. Then it's ene because merong double bond. So this one is an alkene. So the more updated version for this naming is that we we have the prefix first, hex. Then we have the location of the double bond. That's 2. Then we have the suffix for this one. So again, it's an alkene because of the double bond. So this one will be named as hex to ene. So this one is the more updated version for naming of these compounds. Next, we have another one over here. So we have again 1, 2, 3, 4, 5, 6. This is the parent chain over here. Then we have here a substituent. So this one is a methyl group. Now let's name this one. So should we go from left to right or from right to left? So here we have a methyl and we have here a double bond. So here we should we go from left to right or from right to left? If we go from the left to right, this will have number 2, right? So this will have number 2. Pero if we go from the right to left, it will have number 3. So in this case, we should know what should be prioritized first. Is it the double bond or the substituents? So actually here we have the level of priority. So we have prioritization. So in this case, we must prioritize the alkene over the substituent. Again, sorry, over the alkyl group. Alkyl. So again, the alkyl is the methyl over here, the methyl. Okay, so again, on this case, the alkene must be prioritized over the alkyl. So we'll prioritize this one. So we'll give this one the lowest number possible. So that's 1, 2, 3, 4, 5, and then 6. So for this one, we name this one as, again, first we have the substituent first attached on carbon number 4. So that's 4 methyl. And then we have the compound. We have, our parent chain over here. We have hex. Then we have here 2. Then double bond. This one is an alkene. So this one will be named as 4-methyl hex 2-ene. Next, we have the alkyne over here. So here we have at least one triple bond in the compound. So we should name this one again 1, 2, 3, 4, 5, 6. So here we have 6 na carbons. So this will be hex, right? Hex. Then let's name let's number the carbons here. So we have 1, 2, 3. If we go from left to right, and then from right to left, we have 1, 2, 3. So it's the same whether we started from the left to right or from right to left because this triple bond is on the center of this compound. So let's have 1, 2, 3, 4, 5, 6. So here it started on carbon number 3. So we have hex 3. Then again, this one is a triple bond. So pag triple bond, again, the suffix, this one is an alkyne. So the suffix here is "-ine". So this one will be hex 3-ine. Another one over here, we have a triple bond. So this one is an alkyne. Here we have a substituent on this one. Now let's number the carbons here. Again, the alkene must be prioritized over the alkyl. So we should give this one the lowest number possible. So by that, we should go from the right to left. 1, 2, 3, 4, 5, 6, and 7. Now let's name the compound. This one is composed of 1 carbon, therefore this one is methyl. So let's name the compound. So this one is 5-methyl. Then we have 7 carbons on the parent chain. This one is hep. Then the double bond started on carbon number 2. Then again, there's a triple bond over here. So this one is an alkyne. So this one, the suffix will be "-ine". So this will be 5-methyl hep. 2 ion.